Hello everyone, I hope you are doing well. So in this video, we are going to discuss Geeks for Geeks problem of the day, and today's problem is find kth element of spiral matrix, and it is a medium level problem. So the problem is fairly simple. It says that we have been given a matrix of n rows and m columns, and we have to traverse the matrix in spiral order. So they have pretty much explained what is a spiral order. So you have to go first right, then down, then left, upwards, and then again right, and this continues on. If the matrix is big, there will be more number of spirals, right? So among if we traverse the whole matrix like this, we have to find the kth element. So indexing will start from 1. So this is the first element, then second, third, fourth, fifth, sixth, seventh, eighth, like this, right? So this question is fairly simple. The expected time complexities of n into m and space complexity is n into m again, right? So let's see how we can solve this question. But before solving the question, I'd like to give you an understanding of how we should understand this question, and then we'll learn how we can make the computer understand what we are thinking. So we'll create a 4 into 4 matrix. So you see what is happening. The first element is here. This is the first element, then second, then third, then fourth, then fifth, then sixth, then seventh, then eighth, then ninth, 10, 11, 12, 13, 14, 15 and 16. This is how the spiral matrix is going, and this is the correct order of the elements. So let us first understand in a simple human language how human will solve this particular problem. So we see that we are going to the right, and when we hit a end point, we change the direction and then we go downwards, right? And when we hit an end point, we change the direction and then we go left. Again, when we hit an end point, we change the direction and then we go up. But this time you see that the end point was not this particular corner, but the end point was this particular corner. Why? Because I have already been through this particular element once, right? So basically I'm going in a particular direction till I hit an endpoint. So the endpoints are of two types. Either I go out of the matrix or I reach an element which I have already visited. So in this case, this will be the endpoint, right? This point. Now again I change my direction and then go to the right. Again I have hit an endpoint because 5 is already visited. So I change my direction and go down, and I hit an endpoint because 8 is already visited. So I go to the left by changing the direction, and from here you see I cannot go left, I cannot go upwards, and I have completed all the 16 elements of the grid, right? So you see the directions are always in this particular order. It is first of all right, then we go downwards, then we go left, and then we go up, right? And after that we again go right. So this is moving in some cyclic order, that first of all right, down, left and up, and then again right. So this will keep on moving in this particular cyclic order. Now let us formulate what I am trying to say. So I can also write it down. So there are two things that we have observed. Observations, let me call it observations. So the number one observation is that we are moving in 4 directions in cyclic order, and they are, first of all we are going right, then we are going down, then we are going left, and then we are going up, right? And after this upwards we are again going to start with the right. Now the second observation is we keep on moving in a particular direction until we hit an endpoint. So these endpoint is of two types. So the first type of endpoint is we move out of the grid or we reach a visited element, right? So these are the two things that you need to take care of. So if you are familiar with doing DFS or BFS in a grid, traversing the grid would be much easier in this particular case, and I'll explain you also how. So basically what we can do is, this part is very easy to track this particular thing, whether we have moved out of the grid or whether we have reached a visited element. You will be able to do it with a couple of if conditions. Now the question is, how do we traverse in a particular direction? So this is also not very difficult. I just want that the code should be clean and precise. So that's why I'm going to tell you a method with which you can write this code very efficiently. So let us create two arrays, dx and dy. So this is a very well known technique. If you have done grade DFS or grade BFS, you must be already familiar with it. So right direction means in a grid, let's say this is a cell. If I move to the right, my x coordinate will never change, and my y coordinate or my y axis, if I am treating this one as x and this one as y, my y axis will increment by 1. So you will see what happen is there the dx or the change in x will be 0 and the change in y will be 1. Now if I move down, let me just erase some of it. If I move down from this particular grid, you will see my x will increment by 1 and my y will not change, right? Easy. So now what happens if I move left? If I move left, my x is not going to change and my y is going to decrement. Similarly, if I move upwards, my x is going to decrement and my y is not going to change, right? So I have made two arrays. One is a change in x and one is a change in y. 0th position denotes right, and then down, and then left, and then up. Now if I'm at position x comma y and I want to go down, how can I find my next position? I can easily find it by x plus dx of 1 comma y plus dy of 1. So y have taken 1 because at index 1 down is present. If I want to go right, I would have taken 0. If I want to go left, I would have taken 2. If I want to go up, I would have taken 3. Right. So now this problem becomes even more simpler to implement. Right. This detail that I am discussing right now will just help you to implement this problem in a much easier manner. So how will you keep track of these four positions? You can just maintain a variable, let's say current direction. So when you are at 0, you will go right. When you are at 1, you will go down. When you are at 2, you will go left, and when you are at 3, you will go up. So at each stage, when you want to increment, we have said that we are going to visit these directions, right, in this particular order. So first we go right, we will increment the value of current, we will go down, we will increment the value of current, we will go left, we will increment the value of current, we will go up, and then we will again increment the value of current. It's just that since there are only 4 directions, we are going to take current mod 4, right? So whenever it reaches index 4, it is automatically going to index 0. Then again right direction will be followed, right? So you see how simple it is to implement with the help of these two arrays. Otherwise you would be like busy in writing a lot of if else conditions, and that will be a lot of mess. So this really helps to write less code and do this particular DFS or grid traversal much easily, right? So we have discovered how we can traverse the grid in these 4 directions by maintaining these two arrays and a variable current, right? Now this particular part, moving out of the grid is very easy. If your x index goes less than 0, or x index goes greater than equals to n, or y index goes less than 0, or y index goes greater than equals to m, any of those 4 conditions are satisfied, that means you have moved out of the grid, right? So this is for moving out of the grid. If we have visited an element, it can be stored in a visited array, and visited of x, y will denote that it has been already visited. So both of these are pretty easier to implement, right? And this is all you have to do. Now whenever you reach the kth element, you can just return the value of the kth element, right? So this is how I solved this question, and let us have a look at the code now, how we can actually implement it. So these are the same dx and dy array that we have just discussed, and this current variable is going to store the current direction. So 0 means initially we are going to the right. Now we initialize x and y, this will be storing the current position, and both of them are initialized to 0. So we are initially at position 0, 0. And now I have a visited vector, so it is a boolean vector of size n cross m, and it is initialized with 0. That means none of the elements are visited. This is my valid function. We'll come to it in a while, but let us discuss what we have here. So I am running a for loop from 0 to less than n into m, since there are n into m elements, right? I mark my current element as visited, and I check whether the index I plus 1 is equals to k. So why I am checking I plus 1? Because this value is actually from 0. So if you started from 1 and then make this less than n into m, then I can also write it as I is equals to k. So it's up to you what indexing you choose, and according to it you have to put your if condition here, right? Now if this is satisfied, I can just return the current element, that is a of x comma y. Now I check if the next direction I am trying to move into is not valid, right? So the next direction is x plus dx of current and y plus dy of current. right? If it is not valid, I'll update my value of current. That means I have to move to a new direction, right? So how I update it? I do current plus 1 mod 4. You know why I am doing mod 4? Because after this position, after the last element, I have to move back to the first element again, right? So I do mod 4 here, and then I update x is equals to x plus dx of current, y is equals to y plus dy of current. Since my current value will be changed, so my direction of xy or the direction in which I was moving will be changed accordingly, right? Now I have this valid function in which what I do is I take two variables or two positions x and y, xx and yy. I took it differently because I wanted to differentiate from these two positions. Now the same condition for checking whether the index is out of bounds for the grid or not. So x is less than 0, x is greater than equals to n, y is less than 0 or y is greater than equals to m, just return 0 because this is out of bounds. Now if it is not visited, I just return 1, right? So if they visited xx and yy is equals to 1, this is going to return 0. If it is 0, it is going to return 1. That is what this not operator does here, right? So if it is not visited, I am going to get true. Now here also you will see it is not valid, then only I am updating the value of current. So this will be the solution of this particular problem. And remember that we have written these dx and dy in some specific order only. This is right and then down and then left and then upwards. If you change the order, the answer will not work because this is the order we have to visit the grid in, and this is the order of the spiral matrix. So let me just submit it and show you that this particular code works. So you see that it passes all the test cases and this solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video. And don't forget to share your thoughts in the comments because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you and it will be able to reach more number of people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost and you can also subscribe if you don't find the videos interesting later. So share the channel with your friends. Until the next video talks, keep coding, stay safe, bye bye.